Welcome to Mr. Chalk's Revision Tips. In this video, we will look at reactions with oxygen, reactions with acid, and reactions with water. So when metals react with other substances, the metal atoms lose electrons generally to form positive ions. The reactivity series of metals is a chart showing metals in order of decreasing reactivity. So what we're going to look at is when we go and we react metals with acid. When metals react with oxygen, they form oxides. And we're going to have a look at when group 1 metals react with water to form hydroxides. In a reactivity series, the most reactive element is placed at the top and the least reactive element is placed at the bottom. The more reactive metals have a greater tendency to lose electrons and form positive ions. When metals react with water, they form metal hydroxides and hydrogen, for instance. So the extraction method used to extract different metals depends upon the metal's position in the reactivity series. So for instance, if a metal is less reactive than carbon, so a metal oxide, for instance, can be reacted with carbon and the carbon will grab the oxygen off of it, you'd be left with the metal and you'd form carbon dioxide. When a metal reacts with a dilute acid, a salt and hydrogen are formed. The more reactive the metal, the more rapid the reaction is. So, for instance, if we react hydrochloric acid with zinc, we form zinc chloride and hydrogen. So a student investigated the reactivity of different metals. The student used 4 different metals. The student measured the temperature rise of each metal 3 times, and the results are shown in the table below. So if the student was carrying out this, give 2 variables that they should control in order to make it a fair test. So you could have 2 things like the concentration or volume of acid, the mass of a metal powder, the surface area of the metal powder, or if there is any stirring involved. One of the results from the magnesium is anomalous. Which one is anomalous and suggest the reason why? So you might want to go back and rewind ever so slightly and have another look at that table. So the one at 4.2, and it could be any one or any of these reasons. So there might have been a lower mass of magnesium added. The surface area of the magnesium might have been too low. Magnesium might have been coated with oxygen, so forming magnesium oxide. There might have been no stirring, or it might have been stirred too quickly. There could have been an entire variety of reasons. The temperature rose when the metals were added to the sulfuric acid. Give one other observation that might have been made. So you might have seen bubbles of gas being given off, and more bubbles of gas could be seen with calcium than with other metals because calcium is more reactive. When metals react with oxygen, they form metal oxides. So for instance, if we have magnesium plus oxygen, that would form magnesium oxide. Iron and oxygen would form iron oxide. Copper and oxygen would form copper oxide. Corrosion is a natural process which converts refined metal to a more stable form, such as an oxide. It's a gradual process, and in lots of cases we want to look at preventing it. Rust is the red or orange coating that forms on the surface of iron when exposed to air in moisture, consisting chiefly of iron hydroxide and iron oxide formed by oxidation. When metal or a metal reacts with water, a metal hydroxide and hydrogen forms. So examples of this include when sodium or other group 1 metals react with water. So sodium plus water would form sodium hydroxide and hydrogen. Calcium would form calcium hydroxide and hydrogen. So all alkaline metals react vigorously with cold water. In each reaction, hydrogen is given off and the metal hydroxide is produced, which is left behind in the water, making it an alkali. One quick thing is, how could we test for the hydrogen that could be given off? We could test it by burning it, and if it burns with a squeaky pop, then hydrogen has been produced. Thanks for watching.